Thank you for that introduction. As everyone's settling down, I guess, I'll talk to you guys about work I've done for my honors thesis under the supervision of Dr. McCauley on a test of competing hypotheses concerning the impact of demography on cultural evolution. And before we begin, I just wanted to respectfully acknowledge that we're standing on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations. So, the explanation of culture change has been one of the central goals of archaeology for at least the past 50 years. And recently, a new evolutionary approach has been applied to this under the name of dual inheritance theory. And this theory states that both biological and cultural evolution have worked hand in hand to influence human evolution. So where biological evolution has inheritance through genetics, cultural evolution has inheritance through social learning. And within this framework, it has been argued that demographic processes are the single most influential factor concerning culture change. And so it's been used to explain patterns of the emergence of behavioral modernity, technological stasis in the Pleistocene, and technological variability amongst groups. However, there's a slight issue with these explanations because they use three different demographic processes, often not really differentiating between the three of them. And they are population size, population density, and the degree of craft specialization. The population size hypothesis is based on sample size bias. So smaller groups are going to be more influenced by random drift occurrences, whereas larger groups are going to be more shielded from this drift. And the reason for this is that they are more influenced by selection. A larger group has more people, more variability, and so a higher likelihood that they're going to be able to adapt positively to, say, cultural or environmental changes. The population density hypothesis is based on this idea that a denser population is a more connected population. So therefore, it's kind of been used as a proxy for encounter rate between individuals. If you're encountering people more often, you're able to transmit your cultures with them on a more frequent basis. The third is the degree of craft specialization, which we have seen increases as population size increases. And since skill level is a result of practice time, if you're able to focus all of your time on, say, making pottery, you're going to be able to be more skilled at making pottery and be able to make more complex pots than if you had to spend your time doing all the different things. So what we wanted to do was create a study that tested amongst these three hypotheses to see which had the best explanatory value when looking at variability and technological complexity for a group of 27 small-scale food-producing groups. So to get at technological complexity, we used Oswald's Techno unit methodology. Two variables we used. The first is the total number of subsistents. A subsistent is any tool that is used in the processing or procurement of food, and the total number of Techno units. A Techno unit is a physically distinct yet integrated portion of a completed artifact. To get at our demographic processes, we used the electronic human relation area files. It's an online keyword searchable database of ethnographies. From there, we used this data and did two stepwise multiple regression analyses. So our results show a positive linear relationship between population size and technological complexity. As you can see in the two multiple regression analyses results here, population size explains about 35 to 45% of the variability in technological complexity. We were a little surprised by these results. It wasn't what we were expecting, especially given that, as you can see in the middle graph there, previous cultural models that use population size kind of show this tapering off effect. As population sizes get larger, their influence on accumulative cultural evolution kind of wanes, and this is inconsistent with our results. So what we're actually going to be looking at now is the interacting role of demographic factors and selection pressure. Begvari and Foley have argued that large and well-connected populations with high selection pressure are where you're going to see the highest rates of cumulative adaptive culture. And in their study, they used selection pressure was actually equivalent to resource pressure. And there is a little bit of empirical basis for this argument. Keeley has found that an increase in population pressure, which he used as population density and resource pressure, shows an increase in socioeconomic complexity. So based on those two things, we're thinking of looking in that general direction. Another thing we're trying to maybe get at is interconnectedness between groups and also group mobility. And if anyone has any other variables they want us to try, because we've tried a couple so far, I would love to chat afterwards or in the question period. Thank you.